So let's look at the physical and chemical changes, okay? So when we talk about physical changes and chemical changes, we're talking about those changes that has to be, for physical changes, the changes are limited to, there are changes that result in a difference in words, in display without changing the words, the composition. That is, display means their physical characteristics, like their color change, their density, depending on those changes. So these are all called physical changes. And most physical changes are reversible. That is, you can go back to the original substance that you had. So the changes in physical changes, we talk about the texture, the color, the temperature, the shape, the change of state, like the boiling point and the what? Melting point. These are all physical changes. So these physical changes are characterized by what? By properties, physical properties, such as malleability, density, viscosity, solubility, mass, and volume. So in the exam, in your exam, what you have to focus in is on the examples, which I'll talk about as we proceed in this video. So the next one is called the chemical changes. So these changes occurs when the substance's composition is changed, when the composition of the substance is changed. Okay? So and for the composition of the substance to change, it means that the bonds must be broken. Okay? And once these bonds are broken, most of the times it is not reversible. It cannot be reversed back to the original one. Okay? So the following indicate chemical changes, right? Such as change in temperature. Before the reaction, the temperature might be endothermic. After the reaction, it could be exothermic. Okay? So change in temperature, change in what? In color. Now, if you notice, there's a color change here, and also there's a color here also. For chemical changes, example, during your titration now, for example, there's a color change. That's the chemical reaction taking place. So it does not mean that every color change has to do with the chemical reaction. Some color change also are physical changes. Okay? So for color change, we are specifically talking about reactions that leads to color change. That's what we mean by chemical change. Okay? So also talk about the odor. For example, during reactions, odor can be produced. For example, the hydrogen sulfide gas that smells like a rotten egg. Okay, so that indicates a color change, an odor. From the odor of the reaction, you should be able to predict that this reaction has taken place. Some reactions form what we call precipitates. Okay, either at the top or at the down part of whatever you're using to react it. Okay, the last one is formation of bubbles. So reactions can give rise to bubbles, and that's a change that you can use to quantify that this change is a chemical change. Got. So let's look at the differences between physical and chemical changes generally. Okay, for physical changes, no new substance is formed. Nothing new is formed. It's the same thing that started the change that ended the change. Okay, so but in a chemical reaction, new substances are formed, and we call these substances, we call it products, right? The reactant and the product. So products are being formed, which is different from the reactants, right? So the next one is that the change is usually reversible. For physical changes, their changes are reversible most times. For example, if you put salt in water, you can still remove the salt from the water by evaporation to dryness method, right? So it's a physical change. But in a chemical change, usually most of them are irreversible. That is, once the product is being formed, you can't bring it back to the reactant, okay, or form back the reactant. Most of them, not all though, but generally we say that this happens, right? The next one, the molecular compositions remains the same. I've talked about this before. The component of that reaction of what is changing is the same. For example, if you put what example will I use now? Okay, the component. Okay, let me picture something that we can use here. The molecular composition of it remains the same. For example, if you put salt in water, for example, let's use that also as a case study. The component is still the salt and water inside. Okay, it is not going to change. Okay, even if you remove the water and you have the salt, you still have the two components. Nothing new was formed from there. There is no bond breaking. There is nothing. The composition did not break, or how will I put, the bonds were not broken. Okay, so at the end of the day, you will still have your salt and your water when you separate it. Okay, so what I'm trying to say is that the composition of the substance remains the same. It doesn't change. But for chemical reactions, the bonds are broken. Okay, the bonds are broken and you have new substances that are being formed. So that's the difference between physical change and chemical change. So the last one talks about the energy. No new energy is produced. The same energy that is there remains there also. But for chemical changes, energy is what? The energies are, there is a change in energy because there could be evolving heat, that could be, or how do you, that could, heat can be evolved, and this heat evolved can alter the energy of that system. So these are the core differences between a physical and a chemical change. So let's look at examples of this physical change and chemical changes. Okay, so and why we say it's a physical change. The example is melting of an ice. Melting of an ice is a physical change because you can still freeze back the ice. It's a reversible process. Okay, you can still freeze back the water. Sorry, melting of an ice will give you water in a liquid state, right? Then you can still freeze it back. Okay, so melting and freezing of water, melting of ice and freezing of water are physical changes. Okay, boiling of water is also a physical change because when you boil the water, it turns to water vapor. You can still condensate the water vapor to the steam to get back the water. Okay, so these two, boiling and condensations, are physical changes, right? Then dissolving sugar in water or salt in water is a physical change because you can recover it back. Okay, no new thing will be formed. It's just a salt solution and a sugar solution, which you can apply evaporation to dryness, or depending on the method you can use to separate the water from the sugar and the salt. Okay, so magnetization and demagnetization of iron is also a physical change, right? Because you can recover the iron, or from the magnet, you can magnetize an iron and you can still demagnetize it. It's the same thing, right? You can it's a physical change. It's a reversible process. So the last one is evaporation of alcohol. You can evaporate alcohol, you can still recover the alcohol back using some techniques, right? So these are all physical changes. Then for chemical changes, rusting of iron. When an iron rusts, it's a chemical reaction, so you can't get back the iron back. Okay, a new product is going to be formed, which is different from what you already have before. For example, when your iron rusts, you can't recover it back anymore. That's a chemical reaction that's taking place. When you burn your wood, that's a true combustion reaction. When you burn the wood, you can't recover the wood back from the ashes, so it's a chemical reaction. You can souring of milk also, digestion of food, corrosion of metals, fermentation of sugar, photosynthesis of plants, and addition of water to quicklime to form calcium hydroxide. These are all chemical changes because you can't recover it back. It's a chemical reaction. It goes and doesn't come back. Okay, and also you have new products that are being formed, or new things are being produced, which is different from what you already have. So these are the key examples. So in your JAMB, you have to make sure that you know most of these things, because in the JAMB they can ask you, the following are chemical changes except, or which of the following is a physical change. So have the mentality of getting to know what's a chemical change. If you look at all this I've given to you here, these things are giving new things. Okay, when an iron rusts, it's no longer the iron that you have. You have an iron rust, which is different from the iron. All right. When you burn a wood, you don't get back the wood again. The wood has been burnt. So it's a chemical change. The same thing happens to this. Now look at this last one I wrote. This one is different. Addition of water to quicklime. When you add water, this is calcium oxide. When you add water to quicklime, you get a new compound called calcium hydroxide, which is a slaked lime. This is called slaked lime. It's called quicklime. Calcium oxide, calcium hydroxide. This is different from these things that are here. So this is a chemical change. Okay, a new product is formed. That's what makes a chemical change. But these ones, nothing new is formed. Sugar plus water gives you a sugar solution. This is the same sugar, but in solution form. So new thing is not being formed here. But right here, new thing is. So any reaction that gives you a new product is a chemical change. So with this, now you should be able to know the difference between a physical change and a chemical change.